In this video, we're going to talk about all different integration techniques. So the first video, I want to talk about basic techniques using USUP or completer square and using inverse trig and long division. And at the end of this video, we're going to talk about integration by parts. Okay, let's do number one. So this one here, so I'm going to use a general use of u equals 9x minus 2. So when you take a derivative both side, du equals 9 dx. So that will change it to integral u to the negative 3 and dx is 1 over 9 du. So 1 over 9 you can take in the front and du. So you use a power law. So 1 over 9 times 1 over negative 2. When you add negative 3 plus 1, it will be negative 2. And then u to the negative 2 plus c. Make sure you put plus c. And negative 1 over 18, 1 over, it goes on the bottom and then positive exponent. And then you plug back in. So 9x minus 2 square, okay, plus c. So that will be your final answer. Okay, that was A. Now B, integral 1 over x squared minus 2x plus 10 dx. So this one, if you try to use a directly use up, it's not gonna work. You have to have a in terms of x on the numerator. So one way you can do this one is you have to complete the square denominator. So let's do that. X squared minus 2x. And now you add one number to complete the square, right? So b over 2 square, negative 2 over 2 square, so which is 1. So you add 1. So up to here, you can complete the square. But since it used to be 9, it used to be 10, so you have to add the 9. Okay? So then now you can complete the square. 1 over x minus 1 square plus 9 dx. Now, if you memorize this formula here, which is integral a and then a squared plus x squared dx, that is inverse tangent of x over a plus c. Okay, so this is a formula you need to know. So I can change to use that form. I can change a little bit like this way. 3 squared plus x minus 1 squared. So my a is a 3. So I'm going to put 3 here and then put it 1/3 in the front. Because to cancel out, then it'll come back to here. Okay? So only reason I'm making like this format to use that formula. So now that will be then 1/3. So inverse tangent of x is in this case x minus 1 over a is a 3, and then plus c. Then I'm done here. Okay, that's the answer. But what if you forget that formula? Then, so you can do this way too. From here, 1 over x minus 1 squared plus 9 dx. So what you can do is when you take out the 9, factor out, then you can do 1 plus x minus 1 squared over 9 and dx. And then 1 over 9 you can take it out. And 1 over 1 plus x minus 1 over 3 squared dx. Now, let's use a u sub. U is x minus 1 over 3. So du equals 1/3 dx. So that will be 1 over 9 integral 1 over 1 plus u squared. And dx is a 3 du. Okay? So then 3 you can take it out 1/3. integral 1 plus u squared du. So that is the inverse tangent. So 1/3 inverse tangent of u. So you can plug it in. U was this x minus 1 over 3 and plus c. So now you have this answer. So that answer same as this answer. Okay. So if you don't memorize this one, that's fine. You can just change the format and then you can get the same answer. Now, C. So here, e to the x over e to the x minus e to the negative x dx. So best way, this one, you need to change the form. So why don't I multiply e to the x top and bottom? See what happened then? So what I'm gonna do is multiply here e to the x, multiply here also e to the x. Okay, but make sure you distribute. Then e to the 2x, okay? E to the x times e to the x, e to the 2x, and here also e to the 2x, minus e to the negative x times e to the x, it'll be e to the 0 power, so that means 1. Okay, so I changed the format. And then from here, you can use u sub. Let u equals e to the 2x minus 1, right? Then du equals e to the 2x, and chain rule, derivative 2x is a 2 dx. So it will be, so denominator just u. And when you divide by 2 from here, so 1/2 du equals e to the 2x dx. So that portion here, you can change into 1/2 du, right? So 1/2 du. Okay. So then 1/2, you can take it out, and 1 over u du. That is ln, right? So 1/2 ln u plus c. So and then you make sure you substitute back 1/2. Then ln of, make sure you put absolute sign. So this is absolute. And then e to the 2x minus 1 plus c. So that will be your final answer. Okay. So what I did is in the beginning, you change the format by multiplying e to the x top and bottom. Okay. Now let's do D. So this one also complete the square. 1 over square root 27 minus 6x minus x squared dx. So one thing I'm gonna use the formula 1 over root 1 minus x squared dx. That's the inverse sine x. Okay, you need to memorize it. There's something also you need to memorize it. So to do that, I need to complete the square. So what you can do from here when you complete the square, so let's say you take out only inside here, you take out negative x squared then plus 6x, okay, and plus 27. Now b over 2 square, so 6 over 2 square, 9. So I'm gonna add the 9 here, but it's actually you subtract 9 basically, so you have to add the 9 outside. Okay, so then this one negative x 3 square and plus, that's 36. Okay, so I can rewrite this on 1 over square root of 36 minus x plus 3 square, okay, dx. So it's somewhat similar to this one, right? So one thing I need to do then, I'm going to make it 1 like that. So 1 over square root 36, when you take it out, 1 minus then x plus 3 square over 36. Okay, and then dx. So then that's a 1 over root 36 is 1 over 6. You can take it out. and 1 over square root, then 1 minus. You can say x plus 3 over 6, now entire thing square, dx. Okay, let's do u sub. U equals x plus 3 over 6. So du equals 1 over 6 dx. Okay, so 6 du equals dx. So this one will change it to 1 over 6 integral. Then 6 du root 1 minus u square. Okay, then this 6 cancel out. So 1 over root 1 minus u square du. That's nice. That's a form we know this one here. So that's a arc sine. So that's arc sine of u, but you can substitute back. X plus 3 over 6. Okay, plus c. So that will be your final answer. Okay, so that is a D. Now let's move to then E. So this is a definite integral. So you're gonna have only number. So how are you gonna do that? X squared plus 2 over x minus 1 dx. So you need to do long division. If it's a rational expression like that, then you do long division. So x squared plus 2, but make sure you put 0x plus 2 to long division, x minus 1, and x squared minus x. When you subtract, then just positive x. Next one plus 2, plus 1. Then x, right? This time this is x. Next one, negative 1 times 1 is minus 1. When you subtract 3 left. So inside 2 to 4, it will change into your quotient, x plus 1, plus remainder over divisor, which is x minus 1. Okay? You can change it like that first. Okay? Using long division. So it's important. People don't know what to do about it, but make sure if it's a numerator, power is higher than denominator, make sure you do long division. Or it doesn't have to be greater, it could be equal, then also long division. Okay? So now here, x squared over 2 plus x plus, when I'm taking antiderivative of that, this one 3 ln of x minus 1, right? Between 2 and 4. So now you plug it in. So when you plug in 4 first, 4 square, so I'm going to write down 4 plus 3 ln of then 3 minus, when you plug in 2 square over 2 plus 2 plus 3 ln of 1. Okay, we know the ln of 1 is a 0, so it will be gone. This one 16 divided by 2, 8 plus 4, 3 ln 3 minus, and 2 plus 2 is a 4. Okay, so then this 4 cancel out. So 8 plus 3 ln 3 is your final answer. Okay, that's how you're gonna do. Now let's move on to next topic, integration by part. What is integration by part? The formula u dv equals uv minus integral v du. So make sure you memorize this integration by part formula. Then let's start it. A, integral x e to the x dx. Then what is a u? U is, if you have an exponential function and polynomial will be u always. Okay, so u is x, and dv equals e to the x dx. So on the left hand side, this one you take a derivative, so du equals dx, and then this one you take integral, so v equals just e to the x. Now, so uv, u times v, x e to the x minus integral v du, so e to the x dx, right? du is dx. So x e to the x minus integral of e to the x is just e to the x, and make sure you put plus c. So that's your final answer. Okay. Now let's move on b. How you gonna do x square root x plus 1, right? So this one I'm gonna use a u sub. So let's say u equals x plus 1. Okay, and then du equals dx. So integral on the bottom root u, and instead of x u minus 1, and dx will be du. Now next step, you can split it. So u over root u minus 1 over root u du. Okay, so then integral u to the 1 minus 1 half is 1 half minus u to the negative 1 half. You can switch it like that, and then use just power rule. So 1 half plus 1 is a 3 over 2, right? So then 2/3 u to the 3 half minus negative 1 half plus 1 is 1 half. So 2 u to the 1 half when you take integral. Now you substitute back, u was this. So 2/3 x plus 1 3 half minus 2 x plus 1 1 half plus c. So that will be your final answer. Okay. Now the other one you can have. So let me see. Let me erase here. The best way, make sure you pause the video and then figure it out on your own first, okay? Next one, C. So integral x squared ln x dx. The first one, like A, when you do this one, it was a x was a u, right? In this case, u will be ln x, but how do you know? So then I want to memorize these tips. Riyadh. Okay, so it has a this way priority. So what is L stand for? This one is logarithm. Okay, like a log or ln. And what is I stand for? Inverse trig. Okay, what is A stand for? Then arithmetic. Arithmetic means in this case a polynomial like x squared or x like that. T means trig function. Okay, sine, cosine, tangent like that. But make sure inverse trig is a more it has a more priority. Last one, least priority, which is exponential function. Exponential. Okay. So I want to memorize that. So then you know what is in the integration by power, which one is a u. Okay. So let's say u equals then ln x, because logarithm is a highest priority right here. So dv equals then x squared dx. So du is 1 over x dx. And then when you take integral of dv equals x squared dx, it will be v equals 1/3 x cubed. Okay, integral. Now uv, so 1/3 x cubed ln x minus integral v du. So one of the x cancel out, so 1/3 you can take it out, x squared dx. Okay, so then x cubed ln x over 3 minus, when you do power rule this portion here, 1/3, but you have another 1/3 outside, so 1 over 9 x cubed plus c. Then that will be your final answer. Okay, So make sure you remember Riyadh. That's it has a priority like that. Now let's do D. D integral x inverse tangent of x dx. Okay, so inverse trig, it has a more priority than arithmetic, right? So then my u will be inverse tangent x. So dv equals x dx. So du. So derivative of inverse tangent x is 1 over 1 plus x squared. Okay, and then when you take integral of the dv, v equals then 1/2 x squared. So uv 1/2 x squared inverse tangent x minus integral v du. So 1/2 you can take it out, and then x squared 1 plus x squared dx. Okay, so far you have that. Now if you remember what I said earlier problem, this one is you have a rational, and then power is the same, numerator or denominator. As long as your power of numerator is equal to the denominator or higher, then you use a long division. So x squared divided by x squared plus 1. So 1 when you subtract -1. So only that portion here will change it to 1 minus 1 over 1 plus x squared dx. Okay, so that is your that's how you're gonna change it. Now, so 1/2 x squared inverse tangent x, and then minus 1/2. So then this one is when you take integral x minus inverse tangent x. Okay, make sure you put plus c. So x squared over 2 inverse tangent x minus 1/2 x plus 1/2 inverse tangent x plus c. Okay, so that should be your final answer. E integral e to the 3x and cosine 2x dx. So this one, if you use that priority, trigonometry, it has a more priority. So u will be cosine 2x, right? So u cosine 2x, okay? And dv equals e to the 3x dx. So when you take a derivative, du is negative sine 2x times 2, so negative 2 sine 2x. V, when you take a integral of that, 1/3 e to the 3x. So uv, okay, uv, so 1/3 e to the 3x cosine 2x minus integral v du. So when you multiply this constant, negative 2/3, so it will be plus 2/3, okay, and then e to the 3x sine 2x dx. Okay, so you're gonna experience like different method. I method, we call this one I method. Okay, you will see soon. Now let's do one more time. So this portion here, only that portion. So u equals sine 2x, okay, and then dv equals e to the 3x dx again. So du is negative 1/2. No, when you take a derivative, that's cosine 2x times 2. It'll be just 2 cosine 2x. Okay. Now v is when you take antiderivative, 1/3 e to the 3x. So only that portion will be uv. So 1/3 e to the 3x sine 2x minus v du. So 2/3 integral e to the 3x cosine 2x dx. Now, if you look at only this portion, that's same as your original one. I came back to the original one. So let's say we put this one is I for my convenience. That's why we call I method. So entire problem so far, I equals, I'm going to copy this, 1/3 e to the 3x cosine 2x and plus 2/3. Now I'm going to copy this one in here. So that is 1/3 e to the 3x sine 2x minus 2/3, and let's say this also I. Okay, so let's multiply it out. Then this one 1/3 e to the 3x cosine 2x plus 2/9 e to the 3x sine 2x and minus 4/9i. So when you add the 4/9i both sides, it will be then 13/9i equals, so this on the other side. Now 1/3 e to the 3x cosine 2x plus 2/9 e to the 3x sine 2x. Okay. So finally, your I, when you multiply reciprocal of 13/9, which is you multiply here 9/13 both sides. Okay. So then there will be 3/13 e to the 3x cosine 2x plus 2/13 e to the 3x sine 2x, but make sure you put plus c, okay, at the end. So that will be your final answer. Okay, it's a little more complicated. Okay, so we call that one is I method. Okay, now let's move on. Then F. So F here. So x squared and e to the 4x dx, right? So of course x squared, it has a priority because arithmetic. So u equals x squared, dv equals e to the 4x dx. Okay, integration by part. So du equals 2x dx, and v equals 1/4 e to the 4x. So that will be uv e to the 4x like that, minus a v du. So 1/2 you take it out, this one cancel. 1/2, take it out. Integral x e to the 4x dx. Okay. So all right. So this one more time, only that portion. So u again, that is x, dv equals e to the 4x dx. So du equals dx, v is 1/4 e to the 4x. Okay, so only that portion will be uv, so 1/4 x e to the 4x minus integral v du. So 1/4 you can take it out, and e to the 4x dx. Okay, so that's a 1/4 x e to the 4x minus. Then when you take integral of e to the 4x, that's a 1/4 e to the 4x, right? So there's but another 1/4 in the front. So 1/16 e to the 4x. Okay, so that one you plug it into here. So your final answer, x squared over 4 e to the 4x minus 1/2 1/4 x e to the 4x minus 1/16 e to the 4x. And then make sure you put plus c. Now, let's just simplify a little further. So 1/4 x squared e to the 4x minus 1/8 x e to the 4x plus 1/32 e to the 4x plus c. That will be your final answer. Okay. Now, let's move on. So g, integral g 0 to ln 2 and x, that's a hyperbolic cosine. If your teacher doesn't cover this one, you can skip on g. Okay, this one, most BC students, they're not gonna learn, but some school they teach hyperbolic sine, hyperbolic cosine. What is a hyperbolic cosine? Hyperbolic cosine is basically, you have to know the definition. Hyperbolic sine e to the x minus e to the negative x over 2. So that is a hyperbolic sine. Okay, and then hyperbolic cosine is e to the x plus e to the negative x over 2. So relationship is hyperbolic sine derivative is hyperbolic cosine. Hyperbolic cosine derivative is hyperbolic sine. Okay, so that's the relationship you have. Now, so let's go back here. So this one also, what you're gonna do is u first, right? So u is then arithmetic. So I'm gonna use a different color. Let's say u equals x, and dv equals hyperbolic cosine 2x dx. So du equals just dx. V, when you take integral of hyperbolic cosine, so 1/2 by chain rule, and like I said, hyperbolic sine 2x. Okay, using that one. So uv 1/2 x hyperbolic sine 2x minus v du 1/2, you can take it out, hyperbolic sine 2x dx. Okay, so finally then 1/2 x hyperbolic sine 2x minus integral of hyperbolic sine is hyperbolic cosine, but if you consider the chain rule, it'll be 1/4 hyperbolic cosine 2x plus c. So that will be your final answer. Okay, so now let's do, hold on, but this one is you have to do 0 and ln. Okay, so I thought that one is indefinite, but that's actually definite integral. So what you have to do, from here you plug it in 0 and ln 2. So let's plug it in. So 1/2 ln 2 hyperbolic sine 2 ln 2, okay, minus 1/4 hyperbolic cosine 2 ln 2, and minus, when you plug in 0, this one will be 0, this portion, because of this. So you have only negative 1/4 hyperbolic cosine of 0. Okay, hyperbolic cosine 0 is not 0, as you see here. So hyperbolic cosine, hyperbolic cosine 0 equals e to the 0 plus e to the 0 over 2. So that will be 1, right? E to the 0 is 1, so 1 plus 1 is 1. 1 plus 1 is a 2, 2 over 2 is 1. So we know this one is 1. Now, what is then hyperbolic sine of 2 ln 2 is this power, this one you can move it as a power, so ln 2 squared like that, and then ln 4. So let's leave it that way. Then what is ln 4, right? So then e to the ln 4 minus e to the negative ln 4 over 2. So e to the ln, it cancels out, so 4. Now minus what is this? This negative 1 you put here. So e to the ln of 4 to the negative 1 power. 4 to the negative 1 power is 1 over 4, right? So then this one will be 4 minus 1 over 4 over 2. Okay? Because e to the ln, it goes away. So you have only 1 over 4 left. Now this one 4 and 16 minus 1 is a 15 over 2. So 15 over 8. That's hyperbolic sine ln 4. Now what about hyperbolic cosine ln 4? So similarly, only thing difference is this one will be positive based on this definition. So I'll just skip up to here. It'll be 1 over 4 plus 2, right here. Then 17 over 4 over 2. So 17 over 8. Okay. So now, what's your final answer? So let's go back to here. Okay. So that value will be equal to 1/2 ln 2. Hyperbolic sine that ln 4 was 15 over 8 minus 1 over 4. Hyperbolic cosine of that value 17 over 8. And then this one will be hyperbolic cosine 0 is 1, so plus 1 over 4. Let's see, then you have 15 over 16 ln 2. And here minus 17 over 32 plus 4 means if you make it 32, 8 like that. So 15 over 16 ln 2 minus then 9 over 32, right? So that will be your final answer. Okay? A little complicated, but it's good to know about hyperbolic sine and hyperbolic cosine. Now, let's do h. So let me erase here. So h integral 1 to e ln 2x dx. Okay, so I can do both ways. So let's do integration by part, or if you memorize, let's do easier way first. Ln x dx is x ln x minus x. Okay, but this formula is coming from integration by parts anyway. So let's do this way, just integration by part. Then what is a u? U is ln. What is a dv? dv is 1 dx. So 1 is a part of also arithmetic, so logarithm it has a more priority. So u is ln 2x. So du equals 1/2. No, not 1/2. So 2x, and then derivative 2x is 2. Okay, and dx, so which is 1 over x dx. Okay, now v equals x. Now that becomes then uv, so x ln 2x between 1 to e minus integral v du. Okay, v du. So x and 1 over x cancels out, so dx, just dx, 1 to e. So then e ln 2e minus ln 2 when you plug in 1 minus this portion here, just x, 1 to e. So your answer here, then e ln 2e minus ln 2 minus e minus 1. Okay, so your final answer e ln 2e minus ln 2, okay, minus e plus 1. Okay, you can leave it like that. So that's your final answer. Okay, that's for this video, and then I'm gonna talk about the other technique next video.